Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas, and we are using item number 31 of the 2019 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a table representing points on a graph of an exponential function. We need to find the written form that best represents that relationship. All right, so what are we talking about when we're dealing with this exponential function? Well, standard form here, let's break this down. Y equals a times b to the x. And the b and the a are the two terms that we are going to need to kind of discern from this table. All right, so what do we know about the a? Well, the a is a constant, right? And it is going to be many things depending on the context of the problem. So if we were doing some problems with money and investing and compound interest, savings accounts, all of that, that would be the principal. Another way to think of the a is simply to think about it as the starting or the initial amount. So what are you starting with? So we'll see this sometimes in problems about populations or about bacterial growth or anything like that. There's always a starting amount, and then it's getting a little bit bigger or a little bit smaller. If we are graphing it, and this is going to be the most helpful for us, we can think of this as our y-intercept. Why would we think of it like that? Well, because look what happens when x equals 0, right? When we're graphing something, right, and if it crosses the y-axis right there, that's when the x equals 0 is when it crosses that. Well, what happens in this particular equation when you make that x into a 0? Well, then that would be a times b to the 0. Anything times 0 is just 1, so a times 1, so it just turns into y equals a. So if we can figure out where the x is at the 0, then that gives us the a as the y-intercept. So the b here, this is going to be your rate. So your rate is going to either be a growth rate or a decay rate, depending on whether it's getting bigger or getting smaller. So what do we know based on the information in this table? Well, we do know that, look at this right here. That's going to be extremely important. That is going to give us our a. Remember, our a is when x equals 0. Then what is your y, or in this case your f of x? So when x equals 0, f of x equals 18. So we can say with confidence that it is going to be f of x equals 18 simply because the x is 0. So let's get rid of that. Let's get rid of that. Now, two different ways for us to find the b. Since these have a step of 1, okay, step of 1, what you could do is you can take each of these f of x's, these y's, and divide it by the previous one, and you'll get the exact same one. So look at this. Plug them out. 2592 divided by 21.6. Take each one divided by the previous one. It would be the same as 21.6 divided by 18. It's going to be the same as 18 divided by 15. It's going to be the same as 15 divided by 12.5. All of them equals 1.2. We want to make it into a fraction, 6/5. So that gives us our b. And then our x is going to be our step. We don't know whether it's years, months, sometimes it's a time period. Now, if we didn't want to do it that way, another way we could have done it would have been like this. Let's take like this, for example. If this is our f of x, we could have plugged it in. We could have said f of x, which is 15, equals 18 times, and then we're looking for our b to the x, and our b is going to be our -1, right? So then it would have been 15 equals 18 over b. You have to multiply both sides by b to get it out, right? So it's 15b equals 18. Now you divide both sides by 15, and look what you get. b equals 18/15 equals 6/5. Our answer is B.